Welcome everyone. The question that is shown on the screen, it came in CBSE 2026 physics question paper. The phase difference between the two superimposing waves that gives rise to a bright spot in a Young's double slit experiment where n is an integer. Four options are given: 2n pi, 2n pi plus pi by 4, 2n pi plus pi by 2, 2n pi plus pi. So for this we need to understand that when the bright images will form, when the constructive interference will occur, when the two waves are in same phase, just like this and this, then we can say the constructive interference will occur and we will get the bright band in the case of the Young's double slit experiment. But if the waves are in out of phase, then we will get a dark band, and we'll get a dark band in the Young's double slit experiment. Okay, so for this purpose, one thing we need to understand that if one wave is like this, okay, then obviously several parameters are known to us, that is, this is called the lambda. Okay, so if it is lambda, then obviously it is talking about the wavelength. Okay, then if I talking about the phases, it is 0, obviously it is 2 pi, and obviously it is pi. Okay, so from this, one very popular relation can be written, that is the phase difference equal to 2 pi divided by lambda multiplied by path difference. Okay, multiplied by path difference. And these relations basically getting importance when two waves are superimposed coming from two coherent sources. If I say this S1 and S2 are two coherent sources, and this is the screen, and this is the screen, then the wave coming out from S1, okay, just bangs on, we can say, on the screen, and the wave coming out from S2 superimposes on the point P, then obviously the S2 traverses more than that of the S1. Then obviously you can say there is a path difference between the waves coming out from the S1 and S2. So the path difference is very important. So depending on the path difference, the phase difference will occur, and we know that if the phase difference, that is the phi, okay, is the integral multiple, or you can say the even multiple of pi, then you are getting the bright images. And if it is 2n plus 1 pi, okay, then you are getting the, or the odd multiple, then we are getting the dark images. From where it comes, okay, just like if two waves superimposes like this, if one wave is like this, let us say this is the wave 1 and let us say this is the wave 2. Okay, these waves are exactly matches with each other. Okay, it exactly matches with each other. Then if I say this is 0, this is 2 pi, this is pi, this exactly matches with each other. Okay, then we can say these 1 and 2 are in phase, that is, there is no phase difference. Okay, so if it is 0 or it 2 pi or 4 pi, okay, or 6 pi, if these will occur, if these are the values of the phi, you are getting the bright images, what we are basically concerning about when we will get the bright spot. Or if we think of the path difference, then if I just denote it by the del x, if I say, then del x is either 0 or full of the wavelength or twice of the wavelength, okay, like this way. Clear? So now from here we have understood that if one wave just superimposes on each other, if one is like that, okay, here 2 waves are there, one wave and then 2 waves are there, from here to here one wave, from here to here another wave. Okay, if another wave just superimpose on it which is not of that length but exactly matches with that, then constructive interference bright will occur. But if another wave is like this, completely opposite of that, it's out of phase, okay, then in that case a dark fringe will get. So with that, if 1 and 2 if combines in phase, we'll get the bright. Okay, if 1 and 3 combines, that is the out of phase, which is shown here also, then we get the dark. Now let us check the options and try to find it out what it is. Let us start doing from D. Okay, so what is D? 2n pi plus pi. So we can say it is 2n plus 1 pi. Okay, 2n plus 1 pi. So it is directly matches with the dark. So D cannot be the answer. Now let us coming to here, that is 2n pi plus pi by 2. Okay, so if the phase difference is pi by 2, if the phase difference for the part C if I am doing, if the phase difference is pi by 2, then what is the path difference? Think about it. Pi by 2, 2 pi by lambda multiplied by del x. So from that del x equal to pi by 2 multiplied by lambda divided by 2 pi. Pi cancels out. Then what is the path difference? Lambda by 4. Okay, now if I try to draw, how it will be? See, one wave is like this, 1/4 of the wavelength. That means another wave is like this. Okay, when it reaches the peak, then it starts its motion. When it reaches the peak, then it starts its motion. So this wave is like that. If I draw it little bit clearly, I think that will be very easy to identify that one. What is the meaning of the word lambda by 4? If I say this is my first wave, okay, the second wave starts its movement when it just crosses 1/4 of the wavelength, that is this much. So it starts from there. Amplitude is the same. So this is lambda by 4. Then obviously it will form the bright image. Sorry, bright band, bright spot. No. C also cancels out. So these are the incarnation of the pi by 2 or the path difference lambda by 4. We can't get the bright image. Next is pi by 4. So from here, if we check the option B, if I say this is the path difference, sorry, phase difference is pi by 4, then obviously the phase difference that we will calculate, that will be simply lambda by 8. That is also not in phase. When we are getting the bright, it is when it is in phase, that is exactly matches with each other. Lambda by 8 means that is also does not matches. If I draw, it is like that. If this is the wave 1, this is completely a theoretical discussion question along with the understanding, little bit competency based. Okay, so what is the meaning of the lambda by 8? So it is lambda by 4 position. So this is lambda by 8 position. So another wave will start its motion from here. Obviously these are not in phase. Again and again. Okay, we are not getting the bright image. So only one option left. When we can say it is 2n pi plus 0. When the phase difference is 0, path difference is 0, then we are getting the bright spot, because 2n pi, that means the condition of the brightness is filled up, condition of the constructive interference will be filled up. When the phase difference in two wave is 0 or the 2n pi or the integral multiple or the even multiple of pi, then we are getting the bright image in the Young's double-slit experiment. So without knowing anything, just from the theoretical discussions, what we already know from the Young double-slit experiment, we can directly say that the answer is 2n pi, because none of these basically matches. This pi by 4, this pi by 2, this pi, it is a part of the wave. Part of the wave cannot be in phase. Okay, so capital A or the option A or the 2n pi is the correct answer. Thank you all of you.